In an attempt to solve the 13,000-year-old mystery of the mammoth's extinction in North America, investigators traced the fallout pattern of potential alien debris scattered across the continent. They are trying to pin down the epicenter of what they suspect was an apocalyptic cosmic impact. From specks of extraterrestrial dust, a frightening picture begins to emerge.
The type of energies we're dealing with are perhaps 100 times that of nuclear bombs. The intensity, the heat would be incredible. All that stuff heading down range. Now we're talking about millions and billions of bullets extending across North America.
As the team maps the concentrations of possible ET evidence, the trail leads them back to a potential impact zone, somewhere in the northeastern portion of the continent. A region that at the time was encased in the vast Laurentide ice sheet. The fact that no impact crater had been found began to make sense to them. Was it possible the thick layer of ice could have masked the blow to the Earth? To test their hypothesis, they brought out the big gun at NASA's Hypervelocity Impact Lab. Using glass beads to simulate a comet or asteroid, planetary geologist and chief triggerman Dr. Peter Schultz fires pellets at nearly 12,000 miles per hour into an isolation chamber to break down the physics of cosmic impacts.
This is definitely a good suspect. If you think about a murder case, you go after probabilities. Events like this have happened before. Every time I do an experiment, I imagine what goes on. If something like that happened then, could it happen again? Are we the next victims? It makes it an imperative to find out if this really happened.
For Dr. Schultz, there are two possible scenarios for a life-altering impact that doesn't leave an obvious crater. His first shot simulates an airburst, where moments before impact, the comet or asteroid starts breaking up and exploding into multiple fireballs as it burns through the atmosphere.
Oh, look at, see, now you can see this coming down. Small fragments, that's the first arrival, that hits. Kapow! If you were close enough to see that, that would be the last thing you ever saw. Oh, sweet. Really sweet. This is pretty clear. We had a cloud of debris, and the cloud interacted with the atmosphere, heating it up tremendously, slammed into the surface and created a very shallow crater with thousands and thousands of smaller impacts nearby. And it's going to be extremely easy for a little bit of time on the Earth, with all that water and wind, we can erase the evidence. And so we're left with nothing but the traces of this disaster.
The airburst experiment showed that by diffusing the energy at the point of impact, the blast might have left a less obvious crater. But as the debris cloud is ejected downstream, the consequences would be no less deadly. Next, Dr. Schultz preps the chamber for a shot into a block of ice, simulating a 2-mile-thick section of the Laurentide ice sheet.
Oh, man, we smashed this. And you notice that there's a very little crater, hardly any crater at all. The projectile actually went through and hit the bottom, but the crater is extremely shallow. The main thing we found out in the experiment is that the ice acts as a shield, and it absorbed a lot of the energy, a lot of the damage. As a result, the Earth may not have even been scathed. The ice could have cracked, it could have crumbled. When the ice melted, it would have hidden the evidence perfectly.
For the mammoths beyond the immediate impact zone, it's not the first strike that counts. It's the devastating wave of heat and shrapnel that spewed out from ground zero.
We can see the streak come in, the vapor plume come off, ejecta heading downrange, and we see these big, giant blocks that begin to break off due to the shock wave. When you think about an impact, you think about getting hit by the projectile. What's much more dangerous, I think, is all that stuff heading downrange, carrying with it vapor, dust, hot gas, embroiling most of North America. That's the stuff that's really scary.